2, and 8. Okay. Now you need to find the area of this hexagon. Yeah, you need to find what is the area. Now, very difficult at the very first view. It seems to be a very difficult question to solve. Now, this kind of questions are solved by that X factor method, wherein you have to add a few lines or some pictures from your side so as to make it a complete figure. Okay, if you look at it very carefully, if I just fill in the gaps, yeah, if I just introduce this small equilateral triangle here, yeah. By the way, because this angle is 120 degree, if I have a 60 degree angle here, it will be a straight line. Do you agree? This angle is 120 because each of these 6 angles here are 120 each. If I have an equilateral triangle, this will be 60, so that makes it a straight line. In fact, even this will be a straight line as long as this is an equilateral triangle of side length 2. We are bridging this gap. Not just that, we can actually bridge the gap here as well and on top as well. Okay, so that makes it a perfect big equilateral triangle. By adding 3 small equilateral triangles, I can convert this shaded area into a part of a larger equilateral triangle. Okay, and we know that this side length is this equilateral triangle is of length 1, this equilateral triangle is of length 2. What will be the side length of this equilateral triangle? Can anyone tell me what will be the length of this equilateral triangle, or what will be the length of this portion, this side? Anyone? Any suggestions about how this for sure is 1, side length 1. This for sure is, what is this?
6.
Why is it 6?
Because the base is 1 plus 8 plus 2, which adds to 11. So therefore, the other side lengths all have to equal to 11, and 2 plus 3 is 5. So therefore, that would be 6.
Okay, so this side length is 11. That side length should also be 11. And from 11, if you subtract 3 and 2, this should be side length 3. Okay, now that makes it a complete equilateral triangle. By just adding these 3 small equilateral triangles of 1, 2, and 3, 1, 2, and 6 respectively, I get a large equilateral triangle of length 11. Okay, now you're supposed to find the area of this portion, yeah, this central portion. That is obtained by manipulating the area of the large yellow triangle, and from there you subtract the areas of these small individual blue, green, and red triangles. Yeah, so this yellow triangle is this large. By the way, how do you find the area of an equilateral triangle? By the Bodleian theorem, we can find the area as root 3 by 4 into the square of the side length. Okay, so basically this will be this area is going to be root 3 by 4 into bracket. This is 11 squared because the side length is 11, minus 6 squared, the side length is 6, minus 1 square, which is the side length of 1, and minus 2 square, which is the side length of this triangle. Okay, so the area of this is going to be root 3 by 4 into how much? 121, 36, 1 and 4, 36, 1 and 4 subtracted from 121. That gives you the area as root 3 by 4 into 20, which gives you the area of 20 times root 3. Is it 20 times root 3? Is there something wrong here? I think there's something wrong. Something wrong. It should be 5 root 3. No, I think this is somewhere something wrong. It should be 80. Yeah, 121 minus 36 minus 1 minus 4 should be 80. Yeah, so 80 by 4 should give you 20. So answer is still 20 root 3. Yeah. Everyone okay with this approach? The person who asked?